Sometimes we might not know the angles in a right triangle, but we might know the sides of the right triangle. Of course, we can figure out knowing the sides, we can figure out the angles quickly. But there is a faster way to find the components of a vector in the x, y, and z direction by using these sides. And this is based on the Pythagorean triples. Of course, this idea is based on the Pythagorean theorem that is the way we know it right here. For example, assuming that we have these sides, we know the dimensions, we have 3, 4, and 5. In that case, you can see that 3 squared plus 4 squared is equal to 5 squared. That will be the Pythagorean theorem. And when we are squaring and we figure out that is true, we see that this 3, 4, 5, it's a triplet that it's called a Pythagorean triplet. If we multiply these 3, 4, and 5 by 2, then we have 6, 8, and 10. So that those are also a triple that it's having the same relationship that we have see here. And if we multiply by 3, we get another triplet, and so on. So why is this beneficial? Well, let's take a look at this situation where we have this vector, and we want to write Newton's second law. Suppose for the method of joints in this truss that we see here, and we have this FBC that is along this component, the BC. So when we write the method of joints, say sum of forces along the x-axis equals 0, we can see that we have this x component there. And quickly we see that this triangle, this triangle that you see here, it's similar with this larger triangle right there. And we don't have the angles of it, but we have the sides. We don't know this side yet, but it's, as you will see, it's a triple, one of the Pythagorean triple. And the question is, is it for sure? Because this is not 3, it's 1.5. Of course, if we multiply this by 2, then we have 3, then here we have 4, and that will be 5. So that's basically, quickly we figure out that this is a Pythagorean triple. And without calculating the angle, we just say that this will be basically this component, which will be the 4. 2 divided by, if we want to use integer, we multiply it by 2. If we want to not use integers, we can keep it as it is, 2. And then this will be 3, basically. No, that's also be a one number that is, it's better to multiply by 2 to have integers. That's why here I put it positive integers. Basically, that would have been here. This projection will be 4 because this is the leg that would be 4 divided by the hypotenuse, and that would be basically 5. 3, 4, 5. In this case, you can see that we can easily write 40 kilonewtons minus this FBC, this component along the x-axis of the FBC times 4 divided by 5. Of course, if we want to figure out the one on the y direction, it will be 3 divided by 5 for this one. Very simple, very fast. And you can see I kind of developed it in here, how we multiply it, and this we figure out that it's going to be 3, 4, and the hypotenuse is 5, and then the BC component right there, and the BC component on x, BC component on y, and easily, like we develop quickly, we can look at them. Of course, I wrote here for us to understand them, but when we solve equations, we can just by observation, we can write this thing right away. Here it's another situation. For example, imagine that we have this x and y frame and this beam that is there, and we can see, as we said, this is another Pythagorean I didn't put it here, it's coming from another number 5. Here is, as you can see, this is multiple of the 3, 4, 5, but this is another one, another triple, Pythagorean triple, 5, 12, and 13. You can check that with the Pythagorean theorem. But anytime when we have this written like that in a triangle and the numbers, that means it means that is a Pythagorean triple. Otherwise, they will not be given. So we can quickly write them, use them. So, for example, this is the x component, and this vector will be 800 times this side, which is the parallel to the x, divided by the hypotenuse, which is 13. The y component quickly the same way, 800 times 5 divided by 13. I hope it helps. If you do have questions, please let me know in an email. Have a beautiful day.